In this video, we solve some equations with common log and natural log and do these 5 problems. This is part 12 of logarithms. Recall that the log of x is the same thing as the log of x base 10. That's called the common log. And the natural log of x means the log of x base e. That's called the natural log. So we're going to do some problems, solving equations. And here are the directions. Solve for x. We're going to give an exact solution, and then we'll use a calculator to approximate x to 4 decimal places. So here's our first example. Log of x equals 2.3. So the first thing you have to do is remember what the base is. The base is 10. If you don't see a base, it means you could put 10 there. Now we're going to use the meaning of logs. Remember that 10 to the 2.3 equals x. So we could write that, or we can write that as x equals 10 to the 2.3. All right, here's our exact solution right here. There's the exact solution. Now we're going to approximate that. All right, so in our calculator, you have to be able to put 10 to the 2.3. Before using your calculator, let's approximate that. 10 squared is 100, but this is bigger than 10 squared because the exponent is 2.3. So 10 cubed, that would be 1,000. So I'm approximating this has got to be some number between 100 and 1,000. And in your calculator, what you might put in is 10, and then it depends what kind of button you have on your calculator. You might have a little caret. Sometimes people use a little caret, and then you put the 2.3, and then you might put an equal. That's one possible key sequence. Another possibility is instead of a caret, like in my calculator, there's a little y to the x button, and you might not have to put the equal sign. So you'll have to know how to work it depending on what your calculator's like. And when you put it in, you'll get an answer with more than 4 decimals, 4 numerals after the decimal point. But if we're going to round it, it's going to be 199.5262. All right. On my calculator, it goes out to 62315, and so that's why it gets rounded right there. So this is the approximation. So we have the exact answer and the approximation. All right, here's one for you to try. The log of 2x equals 1.7. So try it by putting the video on pause. All right, this is slightly different. Instead of just the log of x, we have the log of 2x. So again, remember, this means the base is 10. So I would have 2x is 10 to the 1.7. So I could write that down first. 2x equals 10 to the 1.7. Okay, but now I have to solve for x. I need to divide both sides by 2. And there's our exact value of x. 10 to the 1.7 divided by 2. Now, you cannot cancel the 2 into the 10. If that was just 10, that would be one thing, but this is 10 to the 1.7, a little bit more complicated. All right, now, how could we approximate that? Go ahead and put 10 to the 1.7. Leave that in your calculator. Do not round it. Divide by 2 and then round it to 4 decimal places. So go ahead and try that. See what you get. Again, everybody's keystrokes are slightly different depending on what kind of calculator you have. When I first raised 10 to the 1.7, I have 50.118723336 showing on my calculator, but I don't round it. I simply take that and in your calculator divide by 2. And then you do the rounding. Never do the rounding until the end. So you have 25.059, and then the next digit is a 3. The next 2 digits are 3, 6, so that'll round up to 4, and then we've rounded it to 4 decimal places. Here's another problem. the natural log of x equals 1.8. So that means that's log base e of x equals 1.8. So we're going to have e to the 1.8 equals x, or x equals e to the 1.8. That's the exact answer. Now remember, e is an irrational number. It's approximately 2.7, but you can't plug in a number for e. You need a calculator that has a button for e, something that says e to the x on your calculator, or you might have ln, and then you might have to do the second function to get the e to the x, as in my calculator. So depending on how your calculator works, you have a certain set of keystrokes. All right, on my calculator, what I have to put in is I have to put in 1.8 first. I put in the exponent first. Then what I put in is I'm going to use the second button, because it happens not to, there's not a button that just says e to the x. I need to press my second button, and then there's a button that says ln, and it says e to the x above it. So that's how I know I'm getting the second. And then I press equal, and I get my answer. So this is a possible set of keystrokes. Again, it really depends on which calculator you're using. So here's what you would get if you did it right. So you want to practice on your calculator. 6.0496 is the approximation. I should say, if you squiggle it, it means it's about equal to it. There we go. One thing you might want to do is see if this makes sense. Well, e is bigger than 2, but let's say it was 2. So it's about 2 to the, well, 1.8 is approximately 2 squared. But it's really bigger than 2, right? So 2 squared would be 4, so it seems reasonable the answer would be more than 4. But if you chose the number after 2, which is 3, 3 squared would be 9. Well, that should have been too big. So 6.0496 seems reasonable. All right, here's a problem for you to try. Natural log of 3x equals negative 1.4. Put the video on pause and see if you can get the exact and the approximate solution for x. All right, so remember, this means log base e of 3 to the x equals negative 1.4. So we have that 3x equals e to the negative 1.4. And if we divide by 3, there's our exact answer. Now, you could leave it like that, or if you want, you could write that as 1 over 3 e to the 1.4. Both of those are correct answers. All right, now let's do the approximation. So see if you could do that all in your calculator. So again, these are the keystrokes I'm going to use. I have to first get negative 1.4. So on my calculator, I have to put 1.4, and then you do the plus minus key or something like that so that you see negative 1.4, and then I do second natural log, and I get an answer. My answer comes up to 0.246596964. But before doing anything else, I now want to divide that whole thing by 3. So my approximation comes at 0.082, and then the next digits are 19, so that's going to approximate to 0.0822. All right, let's do one more. So we've got the log of 2x minus 3 equals 1.5. Remember, that means the base is 10. So 2x minus 3, we're going to put this in exponential form, 2x minus 3 equals 10 to the 1.5. Now we solve this like an equation. We'll have to add 3 to both sides. So we have 2x equals 10 to the 1.5 plus 3. By the way, you could put this on pause and finish it on your own first. And then we're going to divide by 2. And that's it. That is our exact answer. Last thing to do would be to put all that into the calculator. So go ahead and try that. This is where you have to be careful with your order of operations. If you do it correctly, you should get 17.3114. Now, how did I do that? I put 10 y to the x 1.5 equals, to get whatever that equals, I added 3 equals, got some number, and then I divided everything by 2. Now you can check to see if this is approximate by putting this 17.3114 back in for x, multiplying it by 2, subtracting 3, and see if you get the same number as if you do 10 to the 1.5 approximately. All right, so this is practice with calculations using logs and natural logs.